We are going to talk today about index design. And specifically, we're talking about index design in the realm of an existing application, something that has been around for a while, 10, 20, maybe even longer years. So our application is evolving and we need to do something about it. A little bit more about me. As you can see pictured, I am a mom of an adorable 2.5-year-old who I think is the cutest baby on the planet. I am also a full-time database administrator with an emphasis in performance tuning, a lot of which actually starts with this index optimization. I am very good at making more work for myself, which is where a lot of these standards and strategies came from. Thankfully, I love documentation just as much. So I have gotten to a point where a lot of this is written down. So a brief overview. First, we're going to start by admitting that there is a problem, because there's usually a problem. The question is just how big of a problem we're dealing with. Gather all the information that we need as far as conversations we need to have. What metrics to collect? There are a bunch of different places we can pull data from. We'll talk about which ones are the most important. And then finally, the most important is our strategy, our plan of attack to take what we've been given and make it better. So the problem looks a little bit like this. I'm going to go screen to screen to screen. And that loading bar, that little blue circle that's saying, hey, I'm going to take a little while. Our favorite timeout warning. We see this on the database level. We see this in the application. And if the engineers have done their job well, then we'll actually see it in some of the application event logs as well. Dealing with high weights, both at the database level, the server level, and then at the interface level. Inconsistent performance between clients, between users, you name it. But ultimately, no one screen is the problem. Our favorite, everything is slow. So helpful. Let's talk about what we can do about that. First, we have to figure out where the problems are coming from. Most common, we're dealing with some performance issues in monster procedures. There's whole hours and hours of talks on dealing with these monster store procedures. A lot of tuning per query. Don't tune the query. We've all heard it. And no upkeep, because managing a database is a repetitive process where you have to constantly be checking in, making sure that as features are being created, as clients are being onboarded, that the design that you have today is the same design that's going to work in a week, that it hasn't shifted away from how it used to work, what used to be good enough. And then as far as the structures are concerned, things can get out of whack, especially when you have people going in and making changes on a whim, such as the missing index suggestions on execution plans, because SQL loves popping up that little green text saying, hey, I'd love this index, but blind obedience is not always the best plan of attack. Dealing with wide tables, because the more columns in a table you have, the more enticing it is to just index every single one of those columns, which ends up leading to too many indexes, because there is such a thing as too many indexes. Right. We want to avoid that as much as possible, and I've noticed that a common problem is multiple indexes with similar keys and just an additional column tacked on. We'll see what that looks like. I love this quote, because what we see at the database level when we go in is not necessarily going to sync up with what our users are dealing with. For purposes of this demo, I was able to secure a reduced copy of the INDB dataset. Hopefully, Most of you, if not all of you, are familiar with the concept of IMDb. It has media information, movies, television episodes, cast and crew, and the people that correspond to that. We need to understand the use cases. How are the users going in? How are they using the application? What is their goal when they open up the website? Understanding response times. What screens are slow? What screens open immediately? And more importantly is, what screens are they spending the most time on? Because a slow screen you hit once a day is going to be less impactful than a medium load time screen that you hit every 5 minutes. Prime example of a question. Who is that actor? I just got done watching a Lord of the Rings movie. I want to know a little bit more about it. Namely, who this wizard guy is. I recognize his face, but I don't remember his name. The application's able to go through and say, hey, here you go, Sir Ian McKellen, that's your guy. But on the back end, we have a different experience. We have the data retrieval. There are a ton of ways to skin that cat. We have ORMs, such as Entity Framework. We've also dealt with some in-house built ORMs. We've got stored procedures and dynamic SQL, and honestly, some combination of the three is not unheard of. And then some expected design standards. A lot of times you're coming in and there's already standards in place as far as naming and auditing columns and key columns. But the big ones are foreign keys, and kind of an offshoot from that is cascade operations on delete on update, because those are tricky and they're great if used correctly and devastating if not. How normalized the data is, that's going to really contribute to how many connection points you have between your tables. And then logging. And I'm not talking just, security logging or who changed this record when, but I'm talking processes that are blowing up a table. So every time you save a document, is it putting a note into a table? And now you've got this note table that is growing constantly every day, all day. Or a queue table, importing a ton of records to be processed later and then cleaned out. This quote is attributed to so many people. I verified it is not Abraham Lincoln for anybody who's actually seen it. Knowing what tools you have and knowing how to use them is going to be the biggest impact for maximizing your time and making sure that you can make the biggest impact as possible in a short time frame, because your tool set is good, not because you just want to get the job done quickly. So let's start by meeting some of our friends that are already built into SQL Server. Query Store, only available in 2016 and higher. Hopefully, most people are working on getting off of anything lower than 2016, considering support times. Activity Monitor, which is my favorite tool for the in the moment, everything's slow, what is going on? And then extended events. I promise they're not as scary as you think. They can be such a huge help. And there have been a number of sessions that talk about how easy they are to set up. So spend some time, get used to them, really helpful. And then we have some system objects, to name a few because there are so many. Index usage stats. A lot of my process starts at this index utilization point. And then the execution requests, and subsequently the SQL text that is going to take the handle off of the requests and give you that full text. And then some additional friends. I love third-party tools. I think they're great. And I have the benefit in my current company to have access to SolarWinds. My first experience with SolarWinds was Plan Explorer, life-changing. Absolutely love using that tool. You do need to give it an email now, but still free. Couple of their paid platforms is DPA and SQL Sentry. A note, DPA is not SQL Server focused, but SQL Sentry is, if you couldn't tell by the name. Honorable mentions, Redgate SQL Monitor and statisticsparser.com. I used to be friends with this guy and was recently reintroduced and reminded how much I love him. So you're actually going to see some screenshots from this interface. One more note, I am not a sponsor for SolarWinds. I just use their tools constantly. So check them out, especially if your company already has access to them. Take the time to really dig in and learn it. They've got a lot of good documentation. Now let's start pulling in our data. Let's figure out what we need to be gathering, right? So let's look at our data definitions. Let's start with some tables. We have our cinema table. This is our movie table. It's going to tell us, all right, give me some titles. I want to know when it was released, how long it ran, what genres the movie is, as well as the data types. Are we dealing with large objects? Are we dealing with a lot of bits? Are we dealing with varchar versus nvarchar? Our keys, an important thing. I'm going to harp on foreign keys a lot because they are great. Love-hate relationship, but when you're looking at them from the interface level, a lot of information is hidden. Namely, looking at the key name is not going to tell you if it's part of that cascade operation unless the person who created the key explicitly listed it there. And then finally, our indexes. Unless you yourself went through and defined all these indexes, assume that the name of the index is not going to tell you everything you need to know about the structure, because there are many different pieces that make up an index. And frankly, if you tried to fit all of those into the name of an index, 255 characters is a limit, not a goal. So we've got our object list. We can start doing a little bit of a high-level analysis. So we'll start by looking at our row count. We have some tables that have millions of records. We have other tables that have a handful, right? And then whatever schemas are being used. We see here we've got the default DBO schema. We also have this additional media schema. Custom schemas are good for separating subsystems, and they're actually really nice when used correctly. Sometimes we can actually see this correlation between the separation in schema and the rows. And a lot of times when you see this small row set, those are going to be more of the lookup tables, more of those decode tables, not ones that hold any sort of transactional data. We can also make some inferences based on the table names, right? So cast and crew. Movies have cast and crew. It's probably the second most common screen that people look at in IMDb. And then made for TV. Television, TV shows have episodes within them. So it's a pretty easy jump to make to say these tables are related. We also want to make sure that we're grabbing sample queries. You can pull them from, everything we've talked about thus far: activity monitor, DPA, query store, the procedure cache, all these places. Right? And it's important that we grab multiple queries for whatever tables we're looking at, because we don't want to tune the query. We want to make sure that anything that we make is going to make an impact for the betterment of the application, not just that one report. We're looking for that common search criteria. In this example, I'm going to go look for the title of a movie, and I'm going to go figure out who plays that Gandalf guy. And along with that is execution counts. How frequently is this being run? Because the more frequently a script is being run, big script, little script, quick insert, quick delete, doesn't matter. That execution count can really contribute to how big of an issue is compounding. And then alongside is that resource usage. And this resource usage is a good indicator on where to start once you figured out what tables to look at. So as far as usage metrics, let's start with the indexes. Favorite place to start here. This is quite a substantial set of data to just look at all of a sudden. I have a script that I wrote that builds out the definitions. It'll tell me, all right, what's my table, name of the index, how much DML, seek, scans, lookups. You can read all that good stuff. The DML operations, keep in mind that every index that you have on a table needs to have some degree of maintenance anytime that there is a change on the table. Seeks and scans. The golden rule in the early days is seeks good, scans bad. Not always the case. I'm not going to delve really into that, but it is something to keep in the back of your mind in case you were taught that scans equals bad. And then finally, lookups. Lookups are a great metric for picking that first starting point, because that's telling you, do I have indexes that are doing a lot of extra work to get the information that I need? More importantly, are those indexes more useful than the cluster that we have? This process is iterative. Constant improvement. Don't wait until you've figured everything else about this table before you make a change, because a small change can make a big impact. So let's see what I mean by that. Start by creating a lab environment. This would be a local instance on your computer. It would be ideal if you could get a copy of whatever production database you're trying to mess with, because the volume of the data does impact the performance of the scripts, but entertain the idea that you can work with a test environment and still get insight. So we'll start with a locked copy. This is just an exact replica of the structures of production. Hopefully your beta environment matches production to a degree with release cadences. And then a working copy. This is where you're going to do all of your little tweaks. Okay, I think this would be the best idea. Maybe not. Let me do the other one. Because you can use this tandem scripts approach, where you have one script that's run twice, one against your control database and one against your working database, because you're going to get to see those metrics compared between the two of them. And that's for the statistics and also for the execution plans. High level, basic anatomy of a query. This is a very simple query in the grand scheme of things. This is what's running behind the scenes when I say, who's playing Gandalf? We have our joints. This is going to be our connection points, right? We talked about making those logical leaps between tables. And then down here we have our predicates, search criteria. These are commonly the key columns that we have indexed on a table, right? Usually, if we're going to go look at movies, we're going to start by a title. Not necessarily by a genre, but hey, top 25 in adventure is still an option. And then by character name. Our output is a little bit of a different beast, because that's going to be a combination of those keys that are being searched upon and other ones that we only need to display. Right, so these columns can be part of an include on an index, or we can just leave them to be looked up in the off chance that we need them. We'll come back to the script a little later. Briefly touch on the three main index types, right? This is not comprehensive. These are just the ones that we're going to be looking at and working with. Primary keys, unique, non-nullable constraint. This is commonly on an identity column or any other unique identifier, because the whole point of a primary key is to enforce that uniqueness. We have a table episode. We're going to go ahead and add our primary key constraint on that identity column, that episode ID identity column. When you add a primary key to a table, it does default as a clustered index, but it doesn't have to be the clustered index. So when we're talking about clustered indexes, we're talking about almost the polar opposite of the primary key in the sense that it doesn't need to be unique and it can be nullable. And this is going to dictate that physical order of the data. And however you're accessing that information is going to dictate how effective that ordering is going to be. You can have up to one per table, right? Table with no clustered index, you got a heap. But as much as it would be nice to have two clustered indexes so that we can hit 2 points equally, we got to pick one that's going to be the best. So let's look at a different option for a clustered index on this episode table. Okay, this time we'll see a composite key example where we say, all right, my index is going to be on the television ID, the identifier for the series, and then the episode within that series. We'll go over why that's a good option. And then subsequently a non-clustered index. It is also nullable and does not need to be unique. But this aids more so with those lookups, getting the information where we have a point of ingress to go get the information that we need. For example, I'm going to go look for a title. But you know what? I'm going to go ahead and tack on release as well, because they keep trying to make Fantastic Four movies. They keep not doing all that great. So let's just make it easier for our users to go into IMDb, say, give me Fantastic Four, but I only care about the ones that came out before 2020. Maybe you can notice how easily abused that can be. Oh, I'll just give it another index column. Oh, I'll just throw in another includes. And that's dangerous. That thinking is dangerous, but pretty common to end up in that situation. I direct your attention to this lovely Jenga tower. There is no one right move to adjusting indexes and designing these relationships, right? Every application is different. Frankly, every client is going to be some amount of different, and you need to make sure that when you're doing all of these adjustments, that you're accounting for the different scenarios. I need to make sure that this is going to work for my big clients. I need to make sure this is going to work for my little clients, and that there isn't going to be this huge difference in performance between the two of them, ideally. So my first move is always going to be looking for those high lookups. Take, for example, our episode table, right? 2 indexes at the beginning of this presentation is the clustered index on episode ID, our identity, our primary key, and then a non-clustered index on television ID. We're looking at this relationship, seeks and scans on the non-clustered index compared to the lookups on that clustered index. And the first thought is usually, oh, well, my index just isn't big enough. It's not sufficient. It doesn't give me everything I need every time. But let's try to avoid that. Instead, maybe we found a better solution for a clustered index, right? Because column order matters here. When you're going to go look at a TV show, you're not going to say, oh, yeah, I want the episode called The Bridge. Okay, that means nothing in the grand world. No, you're going to say, I was watching this show, and now I'm going to go to episode 3 in season 2 to get more information about it. That point of ingress is more likely going to be your television ID. Let's go ahead. Let's pick a better clustered index. We're going to start with television ID and then add in that episode ID. The clustered index, when it's not the primary key, does not need to include that primary key column. Personally, I have a tendency to add it because television ID isn't as selective, because we've got shows like Days of Our Lives that have hundreds of episodes, one of the longest running series out there, if not the longest. So that television ID isn't always going to be very selective. So we'll throw on episode ID to make it just that much better. So how do we make that decision? Okay, we saw the high lookups, we saw the high seeks, but we need to make sure that we're factoring in all the pieces. So let's start by asking ourselves, is this index I'm looking at part of a foreign key relationship? Is it something that very blatantly is going to be a connection point between A and B? Is it the highest seeked index, right? You'll see some tables within a subsystem, which is where you'll see this kind of the most. Think of televisions and episodes as a subsystem, right? An episode means nothing without a television. It is considered a kind of like a sub-table within that system. So if you have an index or multiple indexes that start with the same key that are consistently how the table's being accessed, that's a good indicator that that might be a better clustered. And if it's very selective, television not as selective, but still probably the second best solution. And if it matches with other used ones, that kind of ties back to that highest seek. Do the indexes that start with the same key, whatever comes after it, does that first key line up with a bunch of other indexes that are also heavily seeked? But then we also have to take into consideration the clustered index, because we want to make sure that we're not trading something really good out with something that was also really good. So we ask ourselves, is it on an unused column? Is it on an identity that's there for the sake of uniqueness? Is that clustered index receiving mostly lookups and table scans? Scans are not necessarily bad, but table scans on large tables is generally pretty bad. Or is it used at all? Like, do we ever have a situation where we're entering that table on that column? All right, let's say, you know what? I don't want to change the clustered. It's doing great, got a lot of seeks on it. So maybe we just need to tweak this index. So let's come back to our anatomy of a query example. Right? When you're looking at these scripts, again, make sure that you're looking at as many scripts against that table as you can, right? Because any changes you make should apply to the majority of them. Obviously, if you've got one report or one little dialogue that pops up and grabs 2, 3 extra information columns, try to avoid a point where you've got one index that covers the whole table, right? Go for that majority marker. Determining what's going to be a good candidate for the include column just within this context is first name and last name for the person. Here in this query, we're not searching for anything on person. We're entering on that identifier person ID, right? And we're searching on the title of the movie and then the title of the character name. But you have to keep in mind your context. This one query doesn't necessarily search on first name, last name. But if I want to say, all right, this Ian McKellen guy, what else has he been in? All of a sudden, I'm searching on first name, last name. All the queries on a table matter to find the best solution. Foreign keys. This is my second favorite place to start. Foreign keys are great. They enforce referential integrity, keep us from having orphaned records that have no way to connect back to context, right? So we have our media. We've got a movie, and there's some amount of cast and crew, because what would a movie be without people? And each one of those cast members is a person, maybe a dog, maybe a cat, but you know, for example's sake, a person. And as people like to do, they like to retire. So we have this actress who decides, I'm done throwing in the towel. I don't want to act anymore. But when we go to try to remove that record, all of a sudden we're stopped because there's this foreign key constraint that says, hey, my crew table needs to relate back to a person. And if I no longer have that connection to a person, all I'll see is Lord of the Rings has this character named Gandalf, but I have no idea who he is. So that foreign key make sure that we're keeping that referential integrity. But then we deal with cascades. They are a tricky beast to deal with because there are a lot of ramifications behind it. Let's say I want to kick out a movie. Let's say the last Fantastic Four movie was awful. I didn't watch it for reasons. So let's just go ahead and unaffiliate ourselves with it. Let's get it out of our database. And the foreign key with the cascade delete allows for this automatic cleanup. I deleted my movie. Boom. Let's go ahead and get rid of all the cast and crew. So we're not sitting in a situation where we have this guy who plays Mr. Fantastic, but what movie did he play it in? That relationship no longer exists. Let's just go ahead and clean it up. But that cascade operation adds work to every change that's made to that database because it has to go back and look, am I still valid? All right, cool. Is there any information I need to clean up? Which is why indexing those keys is so important. Let me show you why. I have my movie table. I'm going to go ahead, find my record. Let's get rid of that Fantastic Four movie. Hit that clustered index, delete the record, done. End of discussion. Then we have that cascade, that tricky cascade. And all of a sudden we have to go back and look at our crew table. Yikes. Our process ends up reading the entire table because that ingress between cinema and crew is the media ID, right? Each crew is tied to a movie, a TV, an episode, right? So we're doing this full table scan to get rid of one record. Yikes. So what can we do to mitigate that? Well, surprisingly enough, you need an index, one index on one column. And all of a sudden, you have a one-to-one operation. 11 million reads down to one. Following that line of thinking is your read to write operations. Okay. We want to make sure that the indexes that we have on our tables are effective without being overhead. Take, for example, this Q table. We're loading up records to be imported into the application at a later date. We don't want users sitting around waiting for this screen to finish. We'll just do it in the background. And we end up with these tables that have a whole lot of write, delete, insert, and then a bunch of scans. Okay. What does it play here? When you have these high in and out traffic tables and these scans, you might notice that without a seek, there's room for a missing index, and that's where analyzing your queries comes into play. It helps us out. If we go through, we see queries against this import Q table that are just insert the records, delete the records, probably don't want to mess with it at all after that. But if you find that there's processes in the application that are going through and saying, all right, import Q, give me the records for this user ID, give me the records for this series, then we need to start looking at saying, okay, maybe I've got a missing index here and trial and error that a little bit. That's why you have a sandbox, trial and error, because there's no one right answer in all situations. And so a lot of this is using that before and after to figure out, is this the best decision? And I love index bloat, love it, because we have to keep in mind how reasonable is it that an index is going to be used. Outside of the crazy fanatics, how many people are going to go in and say, I want to know all the actors with blue eyes that love Chinese food? Well, our statistics show that index is being maintained, but nobody's using it. Whether that's because nobody cares, or maybe the application doesn't even support it. There's no way to go in there and say, give me everybody with blue eyes that loves Chinese. It's not really accomplishing anything. Filtered indexes. They can be great in the right circumstances, but I've so often seen them just not utilized correctly. Combination of, oh, well, they didn't structure the index properly, or, oh, they never actually pass in that, adult bit equals 0, right? And then this overlapping index. I mentioned having duplicates, having the situation where, okay, I've got an index on column. So our crew table, we have that media ID index. Let's also go ahead and throw on salary. And it's used. But then you come along the way, every time I'm grabbing salary, I also want to know what their character name is. Let's just go ahead and tack on title. All of a sudden, that old index that just had salary isn't as used anymore because it's got something a little bit better. It's got that extra information. Those overlapping indexes can oftentimes be combined with the understanding that you don't want to go having a non-clustered index that just covers the entire table. Not the most effective solution. I have seen it be the only solution, but more of a caveat than an actual rule. So let's talk a little bit about what happened, right? We went through, we analyzed our lookups. Let's get rid of some of this extra work. We also went through and made sure that our foreign key relationships are indexed. So that whenever we have that relationship, that connection between A and B, we have a straight line. There's no hopping around, there's no second guessing, there's no, let's just scan the whole table because I don't have any other way to do it. So we managed to reduce our index footprint. Our index is dropped by 4. That's not huge, but when we're dealing with 5 tables I changed, 4 is pretty good. We cleaned up some heaps. The crew table and the person table were both heaps, no clustered indexes. We went ahead and found a good clustered index for it. Our seek to scan ratio, 4 times more effective, where our indexes are usually being seeked on instead of resulting in some sort of scan. And that includes table scans, right? Keep in mind the bigger the table, the type of scan is going to impact how substantial this change is, this improvement is. Then we also had a 50% reduction in lookups because those extra hops are going to make everything slower. If you're familiar with networking at all, if you have to hop, getting from your computer to that website is just going to take longer. So we like to reduce those little hops in between. Let's talk about what we're really seeing. The real money is the application performing better? Index uses are a great place to start to find the problems. But when you want to start building that rapport with the business, saying, look, I did a thing and things are better. Here's what's better. Here's how much better. Because if you can quantify that, you're going to get a lot more street cred with your boss to say, go ahead and take a week to fix these things. Or, okay, go ahead and take 2 hours of engineer time to implement the things that you're talking about. So some of the queries that I ran a ton of times to get the index utilization. Characters in a movie. 519,000 reads, right? Almost 4 seconds of compute time and 2 seconds to actually run it in our before database. If I run that same script in our newly optimized database, compute time, zip. Elapsed time, next to nothing. Reads, 96. That is a substantial decrease. Even something more aggregate focused, the average salary for an actor. 214,000. Whole table scan has been reduced to 1,000 records of reads. And that's across all tables involved in the query, right? All these are a combination across a single query. Compute time, gone. Elapsed time, cut by 25%, cut down to 25%. characters played by an actor. We see a similar improvement here. And then all episodes within a show. I want to know season 2 had some miracle 52 episodes in it. It was a good season. That elapsed time did increase, but that read improvement, that compute time improvement is a big boom because the less resources you're consuming, the better everything around it is going to be. Bring that all together, and you can start seeing where that pressure decrease is really coming into play. So add these all up before versus after, and we see that decreased pressure. 99.7% reduction in reads across the board. 0.6 for your compute time, and an 80% reduction in time to take. Keep in mind, these metrics are for one execution of one script. If you have a successful application, you're dealing with something that is being hit by dozens of people. We have hundreds of people. I don't know what the traffic is for IMDb, but considering I use it at least twice a day, it's probably pretty high. These numbers add up so quickly. And for every user in your application, it's going to make it that much bigger of an impact. And this is the kind of result that we're looking for. We want to be able to say, hey, this report had a tendency to time out on days of our lives because there's just so much information to patch back, to, oh yeah, it takes about 10 seconds now. Is that doable? Probably. Because we're trying to cut back on the impact of our database structure, our application structure on the end user. Work with your team, and that includes the users and the engineers. Just because the engineer comes back and says 4 seconds, that's nothing, don't worry about it. If your user is coming to you and saying, hey, I'm on the screen all day, every day, and I'm losing my patience with it, you need to know these things because that's going to help drive you to your next point of focus. Right? And something I run into is users that have been working with the system for so long that they've just accepted their lot in life. Oh yeah, I can't click that button between 10 and 2 because the whole application comes to its knees. Probably just a missing non-clustered index. And you have to fish that information out of them. Have that open dialogue, have that open rapport with everybody on your team. That's going to tell you where you can make that biggest impact. Getting familiar with your resources, both built into SQL Server based upon whatever version that you're running with, but also anything that your company has given you access to. You walk in and all of a sudden you have access to something like SolarWinds DPA. Take the time to learn those tools because they're there for a reason. Utilize them, especially when you're dealing with anything that costs money, because there's no point in having it if you're not going to use it. So take that time. You'll probably be amazed at how much more efficiently you can get to the root of a problem. And having that local test instance. I use this all the time. I have 2 different products at my company. So I have a before and after of the largest database I can get for each product. So that when I'm testing, I can go ahead and throw my changes in there and then run the script against my control, run the script against my changed, and see that immediate impact. We saw on that previous screen the reduction in reads, compute, elapsed time. That information I can actually glean pretty consistently on my local instance. So having that test lab can be a big help in addressing some of those problems. And then finally, figuring out where to start. I always recommend to start with your index usage statistics, because those high lookups, any of foreign key definitions, and the poor read to write ratio, that is going to be your red flag, right? Your beacon in the night that says, I've got a problem here. Somebody please come look at me. And from there, you can start to go, scrounge through all of your resources to find those queries that are being run against those tables and get that holistic picture. Figure out, is it one thing? Is it this one report? Is it this one user that's causing my problems? Right? Those usage metrics are going to give you that starting point to go and analyze everything else around that table. And that's my presentation. Does anybody have any questions?